Here's one example on the sinking fund method from the notes. You take a $50,000 loan at an annual interest rate of 6%, compounded monthly. And the sinking fund offers 4% annual interest rate compounded monthly. How much do you need to pay as a payment each month if you want to be debt free after 10 years? That is to say, after 120 months. Because from a mathematical point of view, which is like the truth, months is the relevant period. So in the sinking fund method, part of your monthly payment goes towards interest. In this case, it's 50,000 times 0.06 over 12, because each month you pay 0.5% in interest. Plus A, say, where A is how much you put into the sinking fund each month. Introduce a letter for unknown quantities. How do you find A? Well, as usual, you put two things together. Firstly, the key, namely by what factor does money grow each month? Month, 1 plus 0.04 over 12. And you draw a timeline. So here's the timeline in months. 120 is going to be the focal time, because it is at this point in time that you want to have 50,000. So you want the total value of these A's, the 120 A's here, to be 50,000. But you can't just say this is 120A, because they need to be pulled forward to the focal time, 120, using the key. So this will have future value A, trivially. This one will have to be pulled forward once, so you multiply by the factor one time. This guy needs to be moved forward 119 steps, so you multiply that A by the factor 119 times, and so you get an equation. The left hand side is a geometric series. You apply the formula for a finite geometric series, and you just simplify stuff, make A alone, then you use a calculator. You get about 340. So each month you pay about $250 in interest and approximately $340 into the sinking fund. So in total you pay $590 or so, and you state an answer. Right. Credit cards. Make a table. Remember that things happen in the morning. So keep that in mind when you make your table, where you have a number of days of the outstanding balance and the outstanding balance. With the interest rate, if it's given as an annual interest rate, you need to convert it into months. Read questions very carefully. Very carefully, please. And don't forget to actually pay your interest at the end of the month. Profitability index. Notice that we are comparing the total present value of inflows and outflows. So you need to, as usual, have the factor, timeline, move things back to year 0 or time 0. Capitalized cost. You have a nice formula. Just quote any formula you use. Depreciation, the straight line method is simple. Just remember that the total depreciable amount is C minus S, the initial cost minus the salvage value. Sometimes S happens to be 0, but that is not always the case. Sum of digits example, if the useful lifetime is 4 years, initially the value C and the scrap value happens to be 0, the total depreciable amount here is C minus 0, that's to say C. So you chop that up into 10 slices, you lose 4 slices, then 3, then 2, then 1. So here's the depreciation table, which contains 5 numerical rows as you have 0 included. Fixed proportion, you want to work with factors. If you lose 8% of something, you have 92% of it left. That's to say 0.92 times whatever you had. one period earlier on. So if something loses 30% each year, and initially it was 258, then after t years you have 258 times 0.7 to the power of t. Introduce a name for the function, give a domain. So introduce a function, include the domain. If you draw a graph, the axis should meet at the origin. Here you have time in years perhaps, or whatever. Here you have dollars. Or it's the other way around. Sorry. Of course, horizontal axis would be time, vertical axis, dollars or euros or so. So factors is the overall key. And drawing a timeline can be helpful.